So question 15. The diagram below shows the graph of the equation y equals f of x, where f of x equals k, x minus a, and x minus b all squared. Okay, and it shows the graph here. And they ask us to find the values of a, b, and k. Right, well, so let's write out our expression first. So f of x is equal to k, x minus a, and then x minus b all squared. Okay, so you can see from the diagram here we've got two roots. Okay, so we've got x equal to -5 and x equal to 4. Right, so these are going to translate into some kind of roots in here. But how do we know which one is which, right? So this is going to look a little something like x plus 5 and then x minus 4. Okay, so you can see here, right, that there's only one point of contact here. This is joining on here. So you can see that this is one point of contact, a tangent, whatever you want to call it. So this is actually going to be x plus 5 squared, so like a double root. That's what I like to call it. So now you can start to see, okay, I can see where these are going to fit in here. So my f of x is going to equal k, which we still don't know, and x minus a, so a is going to be 4, so that's going to be x minus 4, and then we're going to have here, we're going to have x minus b, we're going to have x plus 5 all squared. So that's the first part done. So to find k, what we're going to need to do is, well, we know a value for one of the y values when we have one of the x values. So what we can do is just substitute x equals 1 and y equals 9 into this expression. So find k sub in 1, 9. Okay, so this is going to be 9 equals k times 1 minus 4 times 1 plus 5 all squared. 9 equals k, and then that'll be minus 3, and this will be 6 squared. So it's going to be k times -3 times 36. Okay, so this isn't, okay, 9, so k. 3 times 36 is going to be 3 times 3 is 90, plus 3 times 6 is 18, so minus 108, yeah, so equals minus 108. So k is equal to minus 9 all over 108. Now you need to be careful that this is actually simplified down to its simplest form. So does 9 go into 108? Well, 9 goes into 10. 9 times 10 is 90, and then 9 times 11 is 99, and then 9 times 12 is 108. So it does simplify down. So it goes minus 1 over 12. Right, so that's your final expression. So your final expression for f of x is going to equal -1 over 12 with x minus 4 and x plus 5 all squared. So they do, so a is equal to 4, b is equal to -5, and k is equal to -1 over 12. There are your expressions there. So that's your 3 marks. You get 1 for each. Yeah. Okay, so the last question, B. for the function f of g of x equals, so for the function g of x equals f of x minus d, where d is a positive, determine the range of values of d which g of x exactly has one real root. Okay, so let's think about this. So if it's going to be a minus, so this is going to be lowering the graph somehow. Okay, so if we want it to have one root, it's going to have to be, so it has exactly one real root. So for the real root, the graph has to be shifted down. It's going to have to be, okay, so shift down there. All right. Okay, so when this is below, yeah. Okay, rambling a bit. So I'll draw a little sketch. Okay, so for there to be one root, okay, this is going to go down, that's going to have to be rid of, this is going to have to get rid of. So we're going to want something that's going to look a bit like this. Boom. So, one sec, not even that close, something like this. Okay, where the only root is this one here, coming down from here, and this root isn't even touching. So to go down that far, there's d is going to have to be greater than 9, because this here is 1, 9. So to go it needs to go down all the way past. So when this is no longer when this is no longer above the or crossing the x-axis, that means it's no longer going to be a root, and the only root is going to come from this part of the graph there. So what kind of, looking for like a nice kind of statement. I think it's just looking for d greater than 9. Sorry for rambling on a bit there, but I just wanted to try and explain it. Okay, so that's the end of paper 1.